So here's a question for you. What's a chemical that helps you digest your lunch, but is also used to strip rust right off of massive sheets of steel? It sounds kind of impossible, right? But believe it or not, there's one compound that leads this fascinating double life.
And that chemical is hydrogen chloride, or, as you probably know it, HCl. In this explainer, we're going to pull back the curtain on its two very different personalities. We'll see how it's made in a lab and find out why it's one of the most important and, frankly, surprising chemicals in our world.
So first up, let's talk about how it earned the nickname the everywhere chemical. You might be shocked to learn that this stuff is, well, pretty much everywhere, from inside our own bodies to the very planet itself. I mean, the sheer variety of places you find HCl is just wild. Inside you and me, our stomach lining produces it as gastric acid, which is absolutely essential for digesting protein. Back at home, it's the powerhouse ingredient in many heavy-duty cleaners. And out in the wild, you can even find it in the gases spewing from volcanoes. Okay, and here's a really crucial point to get your head around. HCl comes in two main forms. When it's a gas, we call it hydrogen chloride, but the moment you dissolve that gas in water, it becomes the super powerful hydrochloric acid that most of us are familiar with. This difference is the key to understanding, well, everything else about it.
Right. Let's head into the lab and see how chemists actually cook this stuff up. How do they prepare pure hydrogen chloride gas? You might think it's a super complex process, but the method, first figured out by a chemist named Glauber, is actually pretty elegant and straightforward.
It really just boils down to these 4 steps. You start with 2 very common things. Sodium chloride, yep, just table salt, and concentrated sulfuric acid. You heat them up gently, and that produces the HCl gas. To make sure it's pure, you pass that gas through a drying agent, often just more sulfuric acid, to get rid of any water. And then you're ready to collect the pure, dry gas.
But hang on, why that specific acid? Why concentrated sulfuric acid? Why couldn't you use, say, nitric acid? It's a fantastic question, and the answer shows off a really clever bit of chemistry.
It all comes down to one little word: volatility. You see, sulfuric acid is non-volatile, which just means it won't evaporate easily when you heat it. If you tried to use a volatile acid, like nitric acid, it would just turn into a gas right along with the HCl, and you'd end up with a contaminated mess. Using a non-volatile acid is the trick that makes sure only pure HCl gas makes it out to be collected.
Controlling the temperature is also a huge deal here. You have to keep the reaction below 200 degrees Celsius, and for 2 really good reasons. First, it just saves fuel. But way more importantly, if you go above 200 degrees, you form this hard, crusty byproduct called sodium sulfate that sticks to the glass like cement and can actually crack your equipment. Not good. So, once you have this pure, dry gas, how do you catch it? You use this really smart method called upward displacement of air. Because HCl gas is a lot heavier than air, you just pipe it into the bottom of a gas jar, the heavy HCl sinks, fills the jar from the bottom up, and literally shoves the lighter air right out the top. It's a beautifully simple way to do it.
All right, get ready for what is, no joke, one of the most visually spectacular experiments in all of chemistry. It's called the fountain experiment, and it shows off one of HCl's most incredible properties in a really unforgettable way. So picture this. You've got a flask, turned upside down, and it's full of dry hydrogen chloride gas. A long glass tube runs from the flask down into a beaker of water below, and that water has some blue litmus indicator in it, which you might remember stays blue as long as things are neutral.
Now watch closely. A single drop of water gets squirted up into the flask. And hydrogen chloride is so unbelievably thirsty for water. Get this, about 450 times its own volume can dissolve in just 1 volume of water. The gas dissolves almost instantly, which causes a massive, sudden pressure drop inside the flask. You've basically just created a partial vacuum. And that's when the magic happens. The normal atmospheric pressure outside is now way higher than the pressure inside the flask. It pushes down hard on the water in the beaker, forcing it up the tube and into the flask in an amazing fountain. And look at the color. The blue litmus water turns a brilliant red the second it hits the flask, proving that it's now an acid.
So, with one incredible visual, this experiment proves 2 fundamental things about HCl. First, it's insanely soluble in water. That's what created the vacuum for the fountain. And second, it's acidic. That's what the dramatic color change from blue to red showed us. Just brilliant.
Okay, so we know HCl is an acid. But if you're in a lab, how can you be absolutely 100% sure you're dealing with hydrochloric acid, or any chloride for that matter? For that,
you need the definitive chemical test.
Now, this test is all about creating something called a precipitate, and that sounds complicated, but it's not. A precipitate is just a solid that appears out of nowhere when you mix two liquids. Just think of it like a little chemical cloud that suddenly forms inside your test tube.
Here's how this cool 3-step test works. First, you add some silver nitrate solution. If there's chloride in there, boom, a thick, curdy white solid, our precipitate, forms instantly. For step 2, you add ammonium hydroxide, and just watch, that white solid completely vanishes, and the solution goes clear again. For the final confirmation, you add a little bit of acid back, and just like that, the white precipitate reappears. This appear, disappear, reappear trick is the unmistakable signature of a chloride ion.
So we've seen how HCl behaves and how we make it, but let's bring it all full circle now and look at the huge role it plays in our day-to-day lives and in the industrial world.
This chart really paints the picture of just how vital it is. Its single biggest use, taking up a whopping 35%, is for pickling steel. That's just the process of stripping off rust and other gunk before the steel gets processed. But it's also critical for making chemicals for dyes and drugs, producing food like glucose, and even helping get more oil out of the ground.
And that brings us right back to its double life. On one hand, it's a life giver in our stomachs, essential for getting nutrition from our food. On the other hand, it's a powerful corrosive agent, cleaning the very materials we use to build our world. It's the same molecule, doing two completely different but equally vital jobs.
So, is hydrogen chloride a creator or a destroyer? Well, the truth is, it's both. Its story is the perfect reminder that in the world of chemistry, a compound's role, whether it's good or bad, is all about context. Thanks so much for joining me.